I think we can start right now with the next presentation. And we have two presentations ahead of us. The first one will be done by Lauri Apple. Sorry.
It's Yabuko today, so I changed it specially for today.
Okay. What?
Yabuko.
Yabuko. Okay.
Yeah.
Of course.
Jabukowska.
Of course. Jabukowska. Perfect. And welcome also Slava Schmidt. Our speakers are coming from Berlin, actually. They are working for Zalando right now, and they are very active in the open source community, and Zalando itself is also very active in the open source community. So right now we have a presentation about Play Swagger. I'm not exactly familiar with it, but I hope to learn a little bit from the presentation. Thank you. Let's start.
Okay. So hi everybody, my name is Lauri, like we said. I'm the open source evangelist at Zalando, and I'd just like to ask a few questions to get to know who I'm talking to today. So how many of you have not heard of Zalando? Okay. So most of you have. So we are a gigantic e-commerce company. We're headquartered in Berlin. And we have started out as an online shop that sells clothing and shoes for men, women, and children. And that image back there is the front page of our website from a while ago because it changes a lot. So we were founded in 2008, and we now have more than 10,000 employees working across Europe. On the tech side, we have 7 tech offices. Most of our technologists work in Berlin. We also have offices in Dortmund, Mönchengladbach, and Erfurt in Germany. We also have an office in Hamburg, a couple people working there, and Dublin, Ireland, and Helsinki, Finland. And the Helsinki and Dublin offices opened last year. So we do business. I think, yeah. Thanks. It's good planning. Oh wait, maybe not. I spoke too soon. Okay, I think it's working. Yeah. So we do business in 15 countries in Europe with more than 17 million customers. And as I recently discovered, we have around 300 open source projects. So what we're going to talk about today is a little bit of the philosophical approach to how we're working, and how we enable projects like Play Swagger to form, and how we support them. So we're going to talk about radical agility, which is a strategy for running a tech team that we have been using since last year. Then the rules of play, which are technical principles that support the radical agility perspective. And open source first, which is fairly self-explanatory, but will provide more details. And then Slava is going to talk about Play Swagger in more detail because he's been working on it for the past 9 months or so. And then he's going to give a short demo. So I'm wondering how many people here who know about Zalando think that we are a PHP shop. Anybody? One person. We were a long time ago. So we started out with PHP and Magento. But this wasn't optimal, as you could imagine. So in 2010, we jumped over to the JVM. And in about 4 months, we completely rebuilt everything. Java, and also added Postgres. And this was great. This did well for us for a while. But the company grew very quickly. And so there were problems as a result. This was a monolith. And we couldn't have new teams come on board to develop quickly. So the effects on the productivity were negative. We had this huge code base with lots of dependencies. Coordination was difficult. And the law of diminishing returns kicked in. The effects on innovation were quite similar. You just couldn't innovate very quickly. You had more bugs because of this amazingly huge code base to maintain. And rigid processes, way more rigid than most creative technologists appreciate. And it also slowed down our growth as a team and as a company because you have this old tech stack. It's not really exciting. It's not great for hiring because nobody wants to really work on it. So this is what radical agility is attempting to solve and has been solving over time. So this is a strategy that was started by a bunch of our tech heads, including Eric Bowman, who you might remember from Guild, and some people have actually worked with him. So he is our VP of engineering, and in 2014, the discussions began among tech leadership about how to create a way more innovative environment for development. And the result was officially launched early last year at a big event where we bussed in the entire tech team. So it was like around 700 people at the time, and put them in a nightclub and told them if they were going to be able to use whatever languages and tools that they wanted to use. So radical agility is based on Daniel Pink's book Drive, which emphasizes 3 pillars for making people happy and productive. And those are mastery, autonomy, and purpose. And we hold this all together with the foundation of trust. So that's the glue that keeps everything running. And if you don't have trust, then you can't really have autonomy because you don't trust people to make decisions. You can't have mastery because they may be limited in what they can actually do on the job. And you can't have purpose because they're being told what to do. How many of you are working in an environment that's similar to this? I'm just curious. Okay. So, it's not as common as I thought. So basically, okay. Did I turn it off somehow?
I can click it.
I think it switched. I can just push this button until we fix it. Okay. So basically, to give concreteness to radical agility, we also have implemented this set of technological principles to drive the development. And they're not all relevant to PlaySwagger, so I'll just focus on 3 of them that are, and that's microservices, API first, and REST. So with microservices, we were able to become polyglot. We no longer had to make engineers use Java, and so they naturally gravitated towards languages they enjoy using, and Scala was one of them, especially in our teams that are working on some of the more brand-oriented and customer-facing operations. So some of those teams started using Scala in 2014. And they chose it because it's JVM-based and it works well with the Java libraries. It also has a vibrant ecosystem. I mean, you're all here today. And it attracts great developers. And we also adopted the rest of the TypeSafe platform, including Play Framework, because of its it's very intuitive to use. It's predictable, scalable, and stable, which is incredibly important for an operation of our size. And it's open source, which is really what we really like that. As far as the API first principle, so this emphasizes really developing the best APIs possible. And so that means designing, documenting, and peer reviewing the APIs before anybody sits down to start coding. And we're also following the REST convention to develop our APIs. So with our business strategy emphasizing lots of public APIs for the brands that we work with, we need a lot of APIs to handle different business situations, and also we're changing our business strategy from just a simple online shop to a whole fashion platform with content management needs and data production and all kinds of different new features that we're adding to the business. So we need APIs to handle all of those functions. And so REST enables us to integrate better with our external business partners, and it also allows us to scale the business as well as the team. But if you've used it, if you've worked in it, you don't know that it's not always easy, and so there is an onboarding process there. To help that onboarding process along, we have an API guild. And one of the results of Radical Agility last year was that we have developed guilds for technical topics, as well as things like badminton, house music. There's hundreds of guilds in our organization now, organized by the technologists ourselves. And some of these are really critical to the business, and the API guild is one of them. So this formed right after Radical Agility, and it sets and documents the API standards for the rest of the team. It's informal, so you can join and sit in as well. It reviews APIs and promotes the API first principle throughout the organization. And it also alerts teams that they can also sit in and review the APIs that they're using. Some of the standards that they've developed over the past year are, actually they've developed quite a lot of them, and it's all compiled into a document that we're hoping to release publicly in the very near future. So hopefully this can be helpful to you. We'll make it available on like our website and things like that. But generally, the standards emphasize ease of use and making sure that they're easy to learn and understand, that they're general and abstracted from specific implementation and use cases, that they're robust, that they have a common look and feel. So we really like it to seem like the same author wrote all of the APIs, and that they follow a consistent RESTful style and syntax. So now I'm going to seg a little bit into gear us towards Play Swagger and how this all came to be. Since last summer, some of us have been meeting as the Open Source Guild, and so this is really to drive open source innovation in the company. Before Radical Agility, there were very few open source projects on our GitHub page. Since Radical Agility, like one of the first slides showed, it's grown to around 300. So that's a lot of work being done in a year. And this dashboard is an open source project of ours that captures all the statistics from our projects in the GitHub organization for Zalando every day and updates it. And so you can see, like, this was from yesterday, the different repositories and members and languages. So if you're interested in this project, I can talk to you about it after the presentation. A part of the guild's work is defining standards and principles like the API guild does for APIs. So I think it was late last year we unveiled our open source first principles. So these were devised by the tech team members of the guild to shape our open source strategy and approach. And the most exciting one for our developers is we're encouraging people to think open source first when they start working on a project from the get-go. So, think about the utility of the project to the outside world. How are you going to make it as useful as possible? We really want to encourage people in that direction, while obviously still serving the business. And because of the microservices environment, we're seeing a lot of projects being developed by teams, so set up to create specific services. And so we encourage them, as part of autonomy, mastery, and purpose, to take ownership of these open source projects, make sure the documentation is good, review the code, fix bugs, respond promptly to requests. Sharing code is also, so if you're developing a library and another team uses it, you open source it so they can use it as well. And this is a great environment for projects like Play Swagger to develop because it's very supportive. We have some teams working half-time, full-time on open source projects, and Play Swagger is one of those. Okay, now when the computer breaks, I don't know what to do. I'm out of machine options here. Maybe we'll go back to the clicker.
The clicker doesn't work.
Okay. It might be the internet, so. Well, while we're waiting, how many of you guys, oh, here we go, okay. Thanks. So Play Swagger, what is this thing? Well, it's an API-first library for Play. And you can get it at this link. You can also find it on Typesave's website because it works with Activator. You can use the Activator template to create your own Play Swagger application. It uses the Swagger API specification as a seamless extension to the Play's routes configuration. And how many of you are using the Swagger specifications? Yeah? Okay, so not too many people yet. Next year it'll be like probably everybody. So why did we need to develop this thing? Well, for a lot of the reasons I've already mentioned, but the rapid growth of our platform and number of teams make it really important for those teams to be able to work together without friction. And so with the Swagger API specification becoming the de facto standard for API development, you have teams that will be familiar with that specification, and it also makes it easier for teams to communicate. And Scala is also being adopted by more and more of our teams, and so they needed a tool like this. We're very excited about reducing waste and making developers happy, so we think that projects like Play Swagger will do that by automating repetitive processes and also helping teams avoid doing the same thing over that another team has done. Wasting time coding unambiguously defined things. And it gives the engineers more time to create stuff like services that we might need. So this project originated last summer, not long after Scala Days. It started with Slava, who will be talking in a minute or two, and another engineer on his team who had been playing around with the Play code base and came up with this idea. And so Wando has a long relationship with TypeSafe. We've been, some of us have been working with them on different projects and things for years. So we reached out to them and asked what they thought of this project and proposed that James Roper, who is the Play framework lead, would oversee it, and we would develop, we would do the coding, and we would also define the required functionality for it. And so they were on board with this, and now it exists. So now you will see part 2 of the talk.
So I will go dark now. Yo. So, hi. So Lauri already talked to you about the company motivation behind the plugin, and we are just developers, normal developers, so there might be or must be something else behind it as well. I would also like to answer the question which probably many of you have: why do we present this stuff here at this conference? And in order to do this, I would like to refer to this person. That's one of my favorite writers, Stanislav Lem, probably many of you familiar with his name. And specifically with his book, Sum of Technology, which is more than 50 years old, and surprisingly it was published first kind of 3 years ago in English. And I had an opportunity to enjoy it 15 years ago in Russian. And why this book? Actually, this was the first time I've seen this concept of intelligence amplifier. So basically, the idea is that we have a lot of tools which amplify our physical strengths, but we have no tools which can amplify our intelligence. So 2 important observations in this area. So first of all, we are not improving during years. So we basically do the same stuff. Maybe we're not focused anymore on survival and reproduction, at least not directly. And we're not that different from each other. Our levels of intellectuality not really differ. And an important question. So in source, is human source of energy or control in system which consists of human and the tool? So what's wrong with tools? Actually, nothing wrong with tools. Tools are amazing. So good tool is essential for programmer. The only thing they cannot do, if you do same stuff, same boring stuff, dozens of times over and over again, they cannot help you. They can reduce the suffering, reduce the pain, but they cannot save you. So we like to go into the direction of using some machinery which can do what tools cannot. So I would like to explain this idea with a couple of examples. Please pay attention on similarities between left part of the image which will come and right part. So like this is an example in metalworks, in wood cutting, agriculture, construction, automotive, publishing. So the commonalities among tools, they require deep understanding of what's inside. They usually require mastery and years to learn how to use the tool. They usually require teamwork because we have limited abilities and other agile stuff as well. So if you go from tools to machines, we actually go from practices to conventions and to implementation details. If I'm a user of a sophisticated machine, I'm not supposed to know what's inside. Actually, only supposed to know how to use its interface. And yeah, that's promising. As just a former Java developer, if I don't need to know what's inside, then probably I can start to build something. Right? So one of examples which could originate from our software domain is a REST architectural style. If you compare it to HTTP, which is standard, we can see that the REST is a convention, or basically a tool. And let's just compare how many results we'll give Google for that. So we actually don't care how HTTP is implemented. We just use it as a machine, but we're still discussing how to do REST properly. And from REST to API in general, so the Lauri already talked about that, so I will skip that. And this definition as well, don't read it. That's the essential part. So the API is basically that's something which is independent of the implementation. So basically the machine. And it would be cool if we could, if it's not important what's behind the API, maybe we could somehow work on that. So let's take a look at our teams, our radically agile microservice building teams. Those from the API perspective, we don't care what's behind. It can be another team, the whole company, or something completely different. We just don't care. And yeah, from team perspective to the architectural perspective, the REST services, they are usually built in some kind of orthogonal architecture, also known as ports and adapters architecture. There are layers, and the outer layer is a framework layer, and then there is an application layer and the core. The orange is basically a contract between two microservices. The API definition, it's given. We cannot change anything in that as soon as it's approved by the API guild, or we shouldn't at least. So if we choose some technology and we already know what needs to be implemented, basically we can do following. In the framework layer, we can give some implementation which is more or less cannot be done otherwise, given some specific technology. The same is for anti-corruption layer, and the part of the application core also could be implemented or can be implemented only in single possible way efficiently. So as a programmer, we just need to code this more or less as code monkeys, and that's not what we want to do. We want to work on something like that, where we can concentrate on the core of the problem. So now I said doesn't matter what's behind the API, and it doesn't true. It's not true. So it does matter what we have behind the API, and actually we do want to give a choice to the programmer what's used as an implementation. Ideally, we could be able to generate different implementations, then compare them based on some criteria and choose the best one. which leads me to the architecture of the plugin I will show shortly. So everybody talks about trees. We got two different types of them, so we probably got the most of them, right? So we use Swagger specification to create an API-specific tree that's kind of not abstract syntax tree. It's very shallow, and it's really very API-specific. The purpose to have this tree is to be able to adapt different specifications format, REST specifications format later. We also want to generate different backends. And for that, we convert the API-specific tree into the rich tree. And the rich syntax tree contains specific information needed to some specific language or framework. So after that, we quite easily can generate the source code. So if you look inside the rectangles, I will skip this. The Lauri already told why we have those technologies. So that's the structure of Swagger specification. That's basically nothing surprising, given that we're speaking about REST. It got a security section, it got a definition section, a list of URLs. Each URL can have HTTP verbs defined, and if each of those verbs can have parameters, different types of parameters like query parameters, path parameters, headers, and so on. So from that, basically, now we are able to generate play routes to connect to the internals of the play. We're able to generate tests with test data, marshalls for specific types of validations, controllers, and of course model. So now I would like to give you a feeling how it all works. So I'm really happy I made a screencast yesterday, because network connection is not really the best one. Before going with the demo, we have this Play Swagger site page on the GitHub, and it has really a long tutorial. So if somebody wants to try it, I will show just a little fraction of it. So the easiest way to create a Play Swagger project is to use Activator. Oh, sorry, that's how can I start it? No, I'm not so happy that I made the screencast yesterday. Yeah. So the easiest way is to use the activator. So we've got a template, and here I'm typing really fast to impress you. Yeah, the good stuff, we won't wait until it downloads all the stuff, and yeah, that gets quick. So here we go. I'm using Sublime because actually there is nothing I would need IDE for, and the clean new project contains an example of controller implementation. It's echo YAML Scala. It's actually how it's generated from the specification, and the echo YAML, which is an actual Swagger specification. Other than that, it basically contains nothing. The logic of the plugin, or better, the logic which is generated, those are 3 URLs contained in the specification. The logic of what's generated connected to the play using this import. Here we go. Nothing else to be shown here. So we basically have the project. Now I start the SBT and run play. Right? switching to web browser and opening the web page. Now it takes some time because underneath there are some magic happens. We generate 15 Scala files and one Java file. Java file is from play itself. So the application is started. That's the Swagger front end. For the REST API, we've got 3 URLs, actually 2 URLs, and one of them have get and post. So we already able to send some requests. Now I will just start test, whatever it means. So you can see that there are some tests generated, and it runs and it tests 2 URLs. One is absent because for get we got nothing, and here we have 2 cases for each URL. One case was green, another one was yellow. So that's the generated test. And beside the test, we have a lot of stuff here, like abstractions of a controller, data generators, models, validators. Everything is automatically generated. So here, for example, there is an I probably will just mirror the display to be able to pause it if needed. Come on. I have no mouse. So here we have 1 green and 1 yellow tests, and the reason for that is actually that in the specification we have no restrictions on which kind of data can be fed into the API, and for that we cannot generate any invalid data, and for empty test set the invalid tests are green. Yeah, nothing's wrong with them. So now in the specification itself, we have an inline definition of the response, which is of type of object, and it has 2 properties, name, a year, both of type string. If you take a look at the model, we can see that there is a case class generated for this inline definition with appropriate property types. So the 404 exception comes from because we have empty ID parameter of type string. So in order to fix this, I will place some restriction into the specification. Let's say it can be, it should be at least 1 character long and at most 100. So that was everything I fixed. I restart the test, and we can see that 404 is gone. So basically, now the empty ID considered to be invalid data, and the valid data is then empty string. So probably that's a wrong abstraction. I will change it to be integer. And the restrictions now will be minimum and maximum value. Just restarting the test, not doing anything else, and get compile error. So the reason for the compile error is that we changed the type, that's in the controller. We changed the type of the input parameter, but in the controller it's returned as it is, but in specification it's defined to be a string. So I need to fix it in the controller to have a right type. Change that. Test once again. So now we have 3 green test cases and 1 yellow. So for post, it's something wrong with the URL. Let's take a look at that. So for post, we have 2 parameters which are in query, and it's probably not good abstraction. Either we want to have some object and we want to send it like request body. So I want to make it explicit and to define a Swagger entity for that. So in definitions part of the specification, I just put the description of the structure of this entity. It has 1 required field, and year is optional. So here we can see that plugin provided a correct error message that something wrong with the specification, with pointing what to fix. So now we have different compile errors in the controller, and the reason for that is that actually anything which is entered in the controller is preserved by the plugin. It just fixed the input type to be entity, so we need to remove old stuff. And now we have post response and entity. They're slightly different because name in one case is optional and in another case is mandatory. So I want the response to be of the same type as my request. That would be normal if I just created something that will be the same. There's still some errors in the controller. And there is no notion of post request anymore because I replaced this in the specification. It was optimized away. So to have correct typing, I will return the same data I get. And I hope there will be 4 green test cases. Yeah, each green test case means there was 100 attempts to feed it with some data, valid or invalid, and they are succeeded. So if, for example, I return a failure from my API, then it will be appropriately caught by the test. The get is not working because for now we cannot test parameterless methods. We just don't know what test data to generate for them. But if we take something which take parameters, yeah, then we have a error. So now, for example, if I forget to implement something, I will simulate it by disabling the whole plugin functionality by disconnecting from play. I will see that we have 3 failing error tests with 404. And of course, I can play with the API in the browser. So I actually, as you've seen, I changed a little bit code in the controller just to make the type safety work. The types play together. The rest was changed in the specification only. So the name can be empty. That's not good. We can introduce some restriction. and this restriction is on the property of the object. It recompiles in the background, and we have an appropriate error message. Yeah, that's actually more or less it. There will be something more in this screencast, but essentially that's the functionality I wanted to show you. And now the question is why we're presenting it here. So basically we think that's kind of a tool that's more of the machine, not of the tool. It doesn't require a lot of mastery and knowledge of internals, and it's kind of not allows you to make fine changes, but yeah, still I think it's just the next generation of the tool for purposes where which can be used for purposes where it's appropriate. So we are working currently as two people, just normal programmers on that, and yeah, of course we would be happy to have more contributions, especially from people experienced in developing tools. Yeah, that's it. I will just let it run, and if you have some questions, I will be happy to answer them.
This is maybe not so much a question about the framework, but about this radical agility idea at Zalando. It's like, because for instance, I'm not a very big fan of big frameworks. Like, I think Play has its good place among enterprise Java beans and Cobol kicks up. And I love Scala because I can build my abstractions from the ground up. So for instance, I love for HTTP things the unfiltered framework. But these are just two random guys from mid-western USA doing it in their spare time. It's lovely. It has everything that's in RFC actually. And if I were, for instance, to inherit or to take over like a microservice in a company, the first thing I would do is just throw away Play and replace it immediately overnight with this very nice framework, because it meets all my my needs. And does it fit inside this extreme agility concept? Could I do that?
That's actually a question on you.
Yeah, I mean, I think it depends on your team. So it's up to the team. If that makes sense, then you could do that.
Right. So I would ask the question, if you like to throw away what already exists and replace it with somebody, I would ask you, why do you want to do that? So, I mean, if it's a microservice, right, then there are two possibilities. It works as expected or it don't. So in first case, you kind of just use it. In second case, you replace it with something else. And if you like to rewrite it for some reason, then you can do whatever you want, basically.
No, I was just thinking that this is a question of technical debt. So I think the big frameworks are incurring extreme technical debt. So this is why I love Scala, because I can fine-grain, I can tailor my abstractions. Okay, you're a fashion company, you understand this idea. Yeah, bespoke thing. Okay, so I don't have all that stuff I don't need. Like in Java, I use Spring, whereas lots of unneeded things. Okay, which I take whenever. Or enterprise Java beans, or this Cobol thingy, it has the same. So Scala is liberating me from all that, and this is why this is what I like.
Yeah, I would say I wouldn't express my opinion about Play framework, but I think its biggest advantage not technical. It's really helping beginners in Scala and web development with Scala to kind of start. I have a lot of teams which I know they started with Play, and then over a year they migrated to Spray, for example. That's kind of happening, yeah. But they usually really want to start with Play because it's a familiar environment.
So I really like the approach of generating adapters and things from a Swagger YAML. How much of the Swagger spec do you support with this?
If we don't count bugs, so then so then actually everything except security, and security we kind of just want to have a right design for that, so that we don't rewrite it after we start to adopt other formats.
And a follow-on question, sorry, I don't want to cut anyone else. So one thing I didn't quite get, you're generating the controller, and then when you change the YAML, I assume the comments on the controller are saying these are the bits that you're allowed to, the plugins are allowed to replace. Did you look at, so that's a bit which I think, well, okay, is there another way where we don't have to give over half of our code? Did you look at sort of ways of using like Scala things like implicits or something? Is that just impossible to do?
No, that's possible. What we do, we kind of, as we're generating the code, we're trying to avoid implicits as much as possible. We can just generate what we need without using them. And the controller itself, it's kind of pain to talk about it because of following. So if you see those comments, they are really markers. So for now we're using this source code without. So the right approach would be probably to parse it in Scala AST and to cut out what programmer has introduced additionally to our generated code. But for now we kind of working with a plain text, and it works quite well if you don't really change a lot in your specification by introducing thousands of new parameters or something like that. Then it works. But we really want to do it differently. As I said, the Swagger specification itself is huge, and alone to implement all of those functionalities, it takes a lot of effort.
I think it's very, very impressive. Thanks.
Thank you.
Okay, I thank you very much for the presentation.
Thank you.
If you will have any more questions to Lauri and to Slava, just catch them in the open spaces. And right now ahead of us is the last presentation. And normally we don't do any break. We won't do any break right now as well. We'll just quickly switch to another laptop. Hopefully the projector will allow us to do that seamlessly. And the next presentation will be getting back to the tools and providing some more insight into how the tools behave in terms of bigger projects. So we will just quickly switch, and we are going to start the presentation.